All right, so we're going to look at piecewise functions. This is the one I was sent as a suggestion, and how to use Desmos to graph and or evaluate piecewise functions. So the first thing to think about for a piecewise function is that it's really two separate equations that are used under different conditions. So the first equation is y equals negative x, used when x is less than 0. So I'm going to type that in. I'm going to use y equals negative x on the condition x is less than 0. So you see these curly braces to restrict the domain or give a condition. The second piece of this equation, or this function, is that I would use as my output y, or f of x here. I would use x when x is larger or equal to 0, greater than or equal to 0. So I'm going to write y equals x under the condition x greater or equal to 0. And I can see this shape is formed, this piecewise function here is formed from the two pieces. I use this y equals negative x curve for values less than 0, and I use the y equals positive x curve for values greater than 0. Now, if you're not interested in just the graph, but also want to look at the function numerically, we can use a table, and we can get Desmos to autofill the table if we put these pieces in function notation. I can't give them the same name. They can't both be called f because then it's not going to know which one I want to use at a certain time. But I could call them different names. So I could call the first part f, for example, if I call the second part g, and I put them in function notation that way. Then when I get into my table, I can start with the first function f, and I'm going to evaluate that at x1 being the table's input column. And then I'll take the second function and I'll evaluate that at x1 as well. All right, and now we can put in a variety of values for x1. So I'm going to put in some things that would fit the first function and some things that would fit the second function. So I'm going to start with, say, negative 10, negative 8, negative 2. Again, just I'm picking some values here, maybe 0, 2, 4, and 10. And so what we're seeing in this table is that it is giving us the correct output to the piecewise function. So when I plug in negative 10 into the original piecewise function, I would look at the two conditions and I would only plug it into the part that was satisfied. So negative 10 is a number less than 0, so it would use the second part of the function. I'm sorry, the first part of the function, this part of the function right here. So I made this condition, so I'm trying to point at. It would not use the second part of the function. It would not use the bottom because the condition is not met. And so Desmos is doing that here as well. It's saying I can't use this condition because it's not met by x equals negative 10. That condition is not met. So the outputs are being given here in these two separate columns to show the output uses the top function for numbers less than 0 and the bottom function for numbers greater than 0. You can see those plots along our graph here as well. All right. Now, by hand, you would just simply check yourself. If I asked you to determine what f of 6 is, you would look at the check and say, does 6 satisfy the first condition? You're like, no, 6 is not less than 0. So I'll ignore the first part of this function. Does 6 satisfy the second condition? Yes, 6 is greater than 0, so I will use the second piece of this function, and I'll get 6 for my output. So if I added a 6, I would expect to see 6 for the output down in the second part of the function. Some piecewise functions have more than just two pieces. This one happens to have just two conditions. Some have 3, 4, 5 conditions. But whatever one, there should only be one function, one part of the function, one row of the function, however you want to phrase it, that the condition is met.